Hello student, today we are going to understand numericals on unit 1, that is the fundamentals of photonics. In the fundamentals of photonics there are two chapters. First is laser and second is optical fiber. However, there are no numericals on lasers, uh, but there are few numericals on optical fibers. Before going to numericals, you must understand how many formulas are there to remember for these numericals. So there are four formulas for optical fibers. As you can see, first one is numerical aperture, second one is fraction index change, third one is critical angle which is denoted by theta c, and the fourth one is acceptance angle, that is theta a. Okay, so this is the first numerical on optical fiber. Uh, Calculate the numerical aperture and acceptance angle of an optical fiber having refractive index of core 1.49 and N2 is the refractive index of cladding 1.44. So first of all, you should know what is the formula to calculate the numerical aperture. As we have seen, numerical aperture is equal to square root of n1 square minus n2 square. So you have to put these values in this equation. What you will get? Square root of 1.49 square minus 1.44 square. So these are the easy calculations. So you can use scientific calculator in the exam. So by calculating this, you will get the answer 0.382. Isn't it very easy? Second question is also asked, calculate the acceptance angle. So you know acceptance angle as theta a, which is equal to sine inverse of numerical aperture. So you have already the numerical aperture value. Just put this value in this equation. What do you get? Sine inverse of 0.382. Now when you get this sine inverse of 0.382, your theta a value will be 22.5 degree. So these numericals are very easy. You just need to remember the formulas and solve accordingly. So this is second type of problem. First read the problem carefully. In an optical fiber, calculate the value of critical angle and acceptance angle. Given is core of refractive index of core and cladding, and refractive index of core is 1.58. So write down n1 is equal to 1.58. Refractive index of cladding is 1.4. Therefore write n2 is equal to 1.4. So you have to calculate critical angle. Therefore theta c is equal to sine inverse of n2 upon n1. So simply just put this value in this equation. What do you get? Sine inverse of 1.4 divided by 1.58. So when you calculate this, sine inverse, this division will come out as 0.886, and when you get the sine inverse of it, you will get the angle as 62.37 degree. Now second is to calculate the acceptance angle which is denoted by theta a. So it is the sine inverse of numerical aperture, and numerical aperture formula is sine inverse of under root of n1 square minus n2 square. So just put this value, you will get sine inverse of, in bracket, square root of what is n1? 1.58 square minus 1.4 square, and when you calculate this, you will get sine inverse of 0.73, and when you get the sine inverse of this, your answer will be 47 degree. So this is the third type of problem. Here it is asked to calculate the refractive index of core and cladding of the material. So you have to calculate N1 and N2, and given is numerical aperture 0.22 and fraction index change is given as 0.012. So here you cannot use the normal formulas. So there is a formula which relates the refractive index with the numerical aperture and index is Na is equal to N1 in square root of 2 into change in the refractive index. So put the values of numerical aperture and change in refractive index, fraction index change in this formula. You will get 0.22 is equal to N1 in square root of 2 into 0.012. So when you calculate this, you will get 0.155 into N1 is equal to 0.22. So from this formula, you can calculate N1. N1 is equal to 0.22 divided by 0.152. So once you know del and N1, so there is a relation between del N1 and N2. So that relation is equal to del is equal to N1 minus N2 divided by N1. So now you can put these values here. Del value is 0.012, which is equal to N1 value, you know that. What do you got the values of N1 by calculating this 1.42. So put the value here 1.42 minus N2 divided by 1.42. So from this formula you can get N2 as, just rearrange this equation and you will get N2 as 1.403. Or if you want to just rearrange this equation, I can tell you N2 is equal to 1.42 minus 1.42 into 0.012, and you will get this final equation. Thank you.